myself Dr. S.R. Sogle, Professor, KIT College of Engineering, Kolhapur. So again, we are going to study about the unit number 5 for the DSP digital signal processing. So uh, actually we studied in the last lecture about why we are going to use the DSP processor as compared to the general purpose processor. So in that there are different points we consider over there. I just take the review of this one. The again how it is supporting the floating point operation. Again how it is supporting for the multiplication, addition. So for that purpose, again because we have to handle the n number of multiplication, n number of addition, and for that a huge mathematics is required. The another thing is that it is also support for the real-time application when we are going to choose the DSP processor. Again, there are, when you observe the, what we can say, that the requirement of the TMS first generation, TMS second generation, how it is designed as per requirement. So there are different 32-bit registers are used, cache memories are used, data memories separate, program memories separate, means as compared to general purpose processor, lot many advantages are there when you are going to use for the real-time application. Now this is the TMS 320C600 series. So when you observe this graph, we found that this is the control optimization for C200, that is the TMS has developed, Texas Instruments developed TMS series. So it is a control optimized innovated first, then again C500 series, and then C600 series. Nowadays the C600 series means what? When you observe this, the C6, 62X, 67X, 64X DSP processors we are using for nowadays, we are going to prefer for this one because it having a high performance, means as compared to all the things, all the initial generation or the initial generation of the TMS series is C200. Okay, and then C500, and then the C600 series is launched in the market. So what are the features of TMS 320 DSP? So this is the TMS 320 DSP family. It consists of fixed point, floating point, and multiprocessor digital signal processors. So TMS 320 DSP have an architecture designed specifically for real-time signal processing. So I already explained about the advantage, how it is applicable for the real-time signal processing. Again, this family consists of many generations, that is the C1X, C2X, C5X, right, that we already studied. C3X, C4X, floating point, specifically it is designed floating point operation. The first line C1, C1X, C2X, C2XX, C5X and C54X, it is used for fixed point operation, right. Then C3X, C4X, it is used again for the floating point operation. C8X, it is a multiprocessor DSP, means either we can select the fixed point or the floating point operation. So now C600 is a very familiar or the popular in the market, which supports for floating point as well as fixed point operation. So that we are going to focus in today's lecture. So digital signal processor, again TMS 320 DSP family, from that TMS 320 C6000 we are going to use here. So fixed point devices are C2 TMS 320 C62X DSP generation and TMS 320 C64X DSP generation. This is suitable for fixed point device, and for floating point device we are using a TMS 320 C67X DSP generation. Okay, so 67X is generally applicable for the, what we can say, that the floating point device. So all three uses, means C62X and C64X and 67X, these are uses well as a TI architecture. This architecture developed by Texas and it having a high result and better result. What is the architecture? Texas Manufacturing Instruments, Texas Instruments have developed over there. So this is the different issue, but as per our application, why we are choosing that I am explaining in the next slide. Then again, it having a high performance. Advanced VLIW means very long instruction word, that is going to architecture, that is going to support for the, these are the support for this all this TMS family or TMS 320 DSP family. Excellent choice for multi-channel and multifunction application, that is also using for this TMS family. Now the Velocity TI advanced features, which includes, what it includes? Instruction packing, conditional execution of the instruction, and we are going to operate for fully pipelined branches. So there are some examples mentioned. Instruction packing means what? It reduced code size, that is a single instruction itself. So means for when you are going to use another type of the algorithm, then we require the bunch of coding, a bunch of what we can say that the instructions or bunch of coding is required. So to avoid this, single instruction only do some that operation. So because of that, it is called as a instruction packing. It code size equivalence for 8 instruction, that is a that code size 8 instructions. So it reduces code size, program fetch and power consumption. When you observe this, when you are going to reduce the code size, obviously program fetching operation again and the power consumption is also going to reduce, because in every architecture we have to fetch the instruction, understand, decode the instruction, that is the understanding, and the execution of the instruction. These cycles are working over there, and to avoid, means if you are going to use reduce the code size, means obviously the machine cycles or the instruction cycles will be reduced, and obviously power consumption is also going to reduce. So that is the main advantage when you are going to this Velocity TI advanced features, that is a Texas Instruments developed these new features. Then conditional execution of all instructions again reduces costly branching, right? So there are some instruction supports for the conditional execution. So instead of the big code for different conditions branching, we are going to reduce the cost. Increase parallelism for higher sustainable performance. Parallel processing, parallelism is applicable here or used here for this TMS family. Fully pipelined branches, zero overhead branching, that is we are using for this TMS family. Now C6X also having the advanced VLIW CPU with 8 functional unit. We are having a 8 unit, basically 8 functional unit, which is very important, that is 2 multipliers and 6 arithmetic unit. Execution up to 8 32-bit instructions per cycle, and develop highly effective RISC like code. So this type of the features are present over there in very long instruction word. So for that VLIW CPU having a 8 functional unit, and these are the features. And CPU also consists of 32 general purpose register, that we already studied in the previous lecture, how what we can say that what are the features are there with the 6-7 series. So here 32-bit register, general purpose register we are using for the processing. Then variable width instruction, it is a flexible type of data, we are using variable width instruction because we required for when we are using a variable width instruction, there are 8 or 16 or 32-bit data we can handle, and it provide efficient memory for that. Then again efficient code execution on independent functional unit, that is the industry most efficient for C compiler on DSP benchmark suite, and also assembly optimized for fast development and also for improved parallelism. For that purpose we are going to prefer this TMS series. It having a 40-bit arithmetic coder and computer intensive applications. Then saturation and normalization for the arithmetic operation. Again it having a field manipulation and instruction extract, set, clear, bit counting, support common operation in control and data manipulation applications. So for that purpose we are using this. Now hardware support for that, it having a single precision 32-bit and double precision 64-bit, and it is also used for floating point operation. Okay. Now, the next one is TMS 320 C67X architecture. So, what it includes that we are going to study here. So, in this architecture, sorry. So, it having a program memory, varying size of data memory, peripherals, direct memory access controller, power down logic, and external memory interface unit, serial port and host post. These are the components, or these are the blocks are present in the when you are using this blocks are present in the what we can say that TMS 320 C67X. Okay. Now, this is the architecture of TMS 3206. So, when you observe this architecture, we found that this block, which is important block here, this block, that is a data cache and data memory. It is a having it will handle 8 16-bit 32-bit data, 64-bit for C64X only, means as per the application 64-bit data also handled by using this one. Okay. So, this is applicable for when you observe this C62X, 64X, 67X devices, we are using this. It is an internal architecture of TMS DSP processor. Okay. It having a, when you observe the top block, this is the this one, that is a programmable cache and programmable memory, 32-bit address and 256-bit data. When you observe this, it is supports for DMA and the floating point operation. When you observe this, the right corner, left corner here, it is a power down unit is present over there. So, power down unit is used to save the energy, save the what we can say that the memory also. For that purpose, we are using a power down energy. How it is helpful, that we'll see later on. Then program fetch, these are the program fetch operation, then instruction dispatch operation and instruction decode operation. This is going to control by using these control registers which are in the right side. So, which is used for to control this program fetching, instruction dispatch operation and instruction decode. Again, when you observe this, the below that there is a data path A and data path B. There are two data paths present over there, that is the register file A and register file B. We already explained that there are 32 registers are there. So, L1, S1, M1, D1 likewise, then D2, M2, B2 and L2. Okay. Now, the details about that we will see later on. So, again it having a control logic, some testing purpose, then emulation purpose and some interrupts that we are going to control. So, emulation and the interrupts are bidirectional, means we are using this bidirectional arrow. When you observe this, the DMA direct memory access, we are going to handle the program memory by using this unit. Then when you observe this data cache and data memory separate present over there to handle the 8-bit or 16-bit, 32-bit or 64-bit data. Okay, and this is the what we can say that the arithmetic and logic unit is also there, which is going to use to handle the arithmetic operation. So, some additional peripherals, timers and to control the serial ports for that purpose, this are present. So, as compared to general purpose processor having a arithmetic logic unit, some registers, right, some interrupts, some serial ports. But some here, when you observe this processor, here we'll get some advanced features, and as per the applications, we are choosing the any type of the processor. Now, this central processing unit, what is the central processing unit? How it works? So, it having a program fetch unit, instruction dispatch unit, instruction decode unit, two data path that we study in the block diagram, each with 4 functional units, that is the one functional unit and another functional unit. The 2 data paths are there. 32 bit registers we are using over there. Then some control registers are used over there to control Some control registers are present, control logic is also there, then test, emulation and interrupt logic is also there. So these things are controlled by central processing unit. What is in the, when you above diagram we studied, this is the whole thing is called as a central processing unit. What it includes: program page, instruction dispatch, instruction decode, data path. These are the registers. Data registers are there, some control registers, some control logic, then it will control the interrupt and emulation. Okay, so this is this part we covered. Now when we observe this internal memory, it having, how the internal memory is there: 32-bit byte addressable address space, then on chip memory is there, some internal on chip memory is there, data and program space is there. Off chip memory also we are going to support over there. Two 32-bit internal ports are, we are going to control two 32-bit internal ports to access the internal data. Single internal port to access a internal program memory, and width of that is 256 bits that we are going to use for the internal memory. Then memory and peripheral operations. So when you, that is a, how we are going to control the memory and how we can control the peripherals. For that, large on-chip RAM up to 7 megabits, program cache is there, two-level cache are already, I explained that, two-level cache are there, 32-bit EMI support, then SD RAM, SB RAM, SBS RAM and SRAM and other asynchronous memories also we are going to support by this this one memory and peripheral option. Then direct memory access, that is the controller transfer data between address ranges in the memory map. So DMA controller has 4 programmable channels and 5th auxiliary channels. So direct memory access, that facility is also there in the this processor. Then it having a EDMA controller which consists of 16 programmable channels that are going to use over there, RAM space to hold multiple configuration for further transfer. It having a HPI, it also having a MCBSP, means multi-channel buffer serial port, that we are using for transfer the data serially. Okay, so for that purpose we are using. It consists of 32-bit general purpose timers, and there are 2 timers are there. So it is generally used for time event, count events, generate pulses and interrupt the CPU, send synchronization event to DMA controller. For that purpose we are using this 32-bit general purpose timers. Then power down logic allows reduced clocking and to reduce the power consumption. So this circuitry generally it is used, it is internally present over there, power down logic, it is used for to reduce the power consumption. So these are the data paths again explained already. So component of data path which consists of 2 general purpose register files A and B, 8 functional units, that is L1, L2, S1, S2, M1, M2 and D1 and D2. So the 4 for L1, S1, M1 and D1 at the one side, and in the block diagram we studied, and L2, S2, M2 and D2 at the other side. So likewise 8 functional units we are going to control by using these registers. Okay, so these are the 8 functional units are present over there. To load from memory data path, that is the LD1 and LD2. To store to memory data path, that is ST1. For loading, LD1 and LD2 is there to load the memory data, and for store the memory data, ST1 and ST2 is used. Then to data address path, that is the data address path DA1 and DA2 is used over there, and data cross path, that is IX and IX 1X and 2X, that is the 2 register file are going to support for cross path. So this is the how the data path are used for data path A and data path B. So when you observe this, so there are some here register files A0 to A16, and the below it is a B0 to B15. Okay, multiply. So this is the register file A, register file B. Then again when you are using this, the internal operation for the data path A is there, how it is used for LD1, LD2, LD1 load operation. For the data path means how it is going to handle for 8-bit, 16-bit. According to that, the data path operation is controlled by using these 2 register files. Okay, now these are the functional units, the 8 functional units divided into 2 groups. of 4, that is a functional units and operation performed. What is that? The fixed point operation, floating point operation. These are the L1 L units. We are going to say that L1 and L2, that already explained, two functional units. 32 or 40-bit arithmetic and compare operation. 32-bit logic operation performs 1 or 0 counting for 32-bit, normalized count for 32 and 40-bit. Arithmetic operation here. So some arithmetic operation are mentioned over there. It is used for that. Okay, S unit is used, S1 and S2, use of that 32-bit arithmetic operation, again 32-bit logical operation, bit shift register, again register transfer to and from control register. For that purpose we are using a S unit, that is a S1 and S2 unit we are using. Again some compare operation, then reciprocal and reciprocal square root operation, absolute value operation. So for that purpose we are using this S unit. M unit is used for multiplication, multiply operations, specifically M1 and M2. So these are used for here. When you observe this is for 16-bit and this is for 32 by 32-bit fixed point operation. D unit is used for, that is the last unit here, D1 and D2, for addition, subtraction, 32-bit addition, subtraction, right? Then linear and circular address calculation, load and store operation, load and store for different bit operation we are using. So double word if we want to use, for that we are using this side of the operation, right? Then general purpose register files are there, that I already explained. There are 16 valid register pair for 40-bit and 64-bit. Okay, so likewise 40-bit and 64-bit for that. And in assembly language syntax, a colon between the register names denotes the register pair, that is A1 colon is there, A0, this is the register pair, A2, A3, A4. Likewise we are using for B series also, and it is applicable for the device C62, 64 and 67X. Okay, so this is the some register files are mentioned over there. So thank you very much. I have already explained about details about the internal architecture of TMS 67X series. So thank you very much.